Question 14. So let's have a little think about what it tells me about the capacity. So if I think about that is volume. So the volume of a cylinder is pi r squared multiplied by the height. Okay, so got a little cylinder. There we go. Now we know that that's equal to 500. So milliliters, that would be 500 centimeters cubed. So we know that's going to be equal to 500. So what we want to do is we want to rearrange this part here to write h equals. So if we just divide by pi r squared. So let's keep that in mind, because we're going to need that in a minute. Now let's think about the surface area. So how would you work out the surface area of a cylinder normally? Okay, so to work out the surface area, what you would do is you would have, so you'd have 2 pi r squared, wouldn't you? So you've got 2 circles. And then you've got the rectangle in the centre. And that's going to be, so you've got 2 pi r multiplied by the height. Now, we don't want that to be part of this formula, right? So we want to be able to take that out. Now, we know that the height is equal to 500 over pi r squared. That's why they told us this little bit of information up here. So we're just going to sub that in down here. And then let's see what happens. So we're just going to replace this part just here. So let's see what happens to that. So we've still got 2 pi r squared plus 2 pi r multiplied by 500 over pi r squared. Can have a little bit of cancelling out here, look, because these guys are going to cancel, and that's going to cancel with one of those there. 2 times 500 is 1000 over r, and obviously we still got that part there. So great, that's where we were trying to get to. Right, so let's have a look at part B. So it says, given that the radius can vary, find the dimensions of a can that has a minimum surface area. So we got S equals something to do with R. So that's telling us to differentiate it, isn't it? It's telling us to work out ds over dr. So let's work that out. So if we were going to differentiate this, what would it give us? So this bit here, so multiply by the 2, that gives me 4 pi r. Now, this part, I would write it like this. Just make it easier for yourself. Multiply by the minus 1. So it's going to give us minus 1000. And then it'd be r, then reduce that by 1. So you got to the minus 2. Right, where's the minimum point going to be? So the minimum point is when ds dr equals 0. So in other words, we need to find out, so what value of r will make this equal to 0? So 4 pi r minus 1000 r to the minus 2 equals 0. Right, add this to both sides. And 1000, I'm going to put it over r squared. It's just a little bit neater. What should we do? Should we divide both sides by 4? So that can, and bring the r squared up here. So we're going to have pi r cubed equals 250. And then what we're going to do is we're divide by, I don't know why I took that r up there, divide by pi. So let's have, so r cubed equals 250 over pi. So r equals the cube root of 250 over pi. So if you do that on your calculator, I think it turns out to be 4.2. 4.3. Right, so that's great. We've got that. It did say any dimension, so don't forget what's the height, all right? Because that's the other dimension, right? It'd be really easy to miss it out. So it says find the dimensions, so we need to give the height as well. So we've got the radius, right? That's brilliant. So all we really need to do here is that if we just take that and then sub it into here, and if you sub it into here, then you'll get the height ends up being to one decimal place. I think it's 8.6. Right, that's just subbing in that 4.3 into there. And don't forget about the last bit of the question as well. It says with reference to the shape of the can, so just a reason why the company may not choose to manufacture a can with a minimum surface area. So the sensible thing to do is, the math says that they should do it with 4.3, but it might not fit into the hand. So we need to take in consideration how it fits into the hand. Actual drinks cans, I think, have a slightly less radius on there. So 4.3 might be slightly big. And also, I think that would be enough for the mark there. What about the logo design? Maybe that needs to be taken into consideration about how big they want it to be. But the key bit is how it fits into the hand.